In this video, you will learn about zero and negative exponents. Now, negative exponents is a little unusual, and to explain, there are two different approaches in which we can think of this. So the first way is as follows. Now, we know 10 to the third power means 10 times 10 times 10, which would be 1,000. All right. 10 squared is 10 times 10, which is 100. 10 to the first power is just 110, so my answer is 10 for that. And if you keep this pattern going, so look on the left side, we have 3, 2, 1 for exponents, which means the next one is going to be 10 to the 0 power. And then on the right side, notice the pattern as well. Each time we are dividing by 10. Right? So if I keep that pattern going, 10 divided by 10 would give me 1. So I have 10 to the 0 power equals 1. All right, so notice that this to the 0 power is 1, and actually anything to the 0 power would equal 1. So it could be the most bizarre thing that you can see. It could be maybe like x minus 2 over x squared plus 3x minus 4, all that raised to the 0 power. Well, it doesn't matter what's inside. Whatever it is, it's raised to the 0 power, which would equal 1. So anything to the 0 power is 1. And now keeping the pattern going even further. On the left side, we would have 10 to the negative first power. Right, each time we're subtracting 1, 3, 2, 1, 0. Next would be negative 1. Keeping that pattern going on the right side as well, we have 1 divided by 10, which would be 1 over 10. So 10 to the negative first power is equal to 1 over 10. Okay, and then 1 over 10, I could think of that as 1 over 10 to the first power, right? Because 10 is the same thing as 10 to the first power. Now if we continue this pattern, the next number on the left side would be 10 to the negative second power. And on the right side, we do 1 over 10 divided by 10, which would be 1 over 100. And 100 is 10 squared. So we can think of that as 1 over 10 squared. Keeping this going, on the left side, again, we would have 10 to the negative third power. And on the right side, 1 over 100 divided by 10 would give me 1 over 1,000. And 1,000 is the same thing as 10 to the third power. All right, so notice what is happening with the negative exponents. The negative exponents means 1 over something. All right, so we have 1 over 10 to the positive first power right here. With the negative 2 for an exponent, that's going to be 1 over 10 to the positive second power. So to make this from a negative to a positive, I simply write as a fraction and put it down in the denominator. All right, 10 to the negative third power is 1 over 10 to the positive third power. So notice that pattern. All right, so negative exponents means a fraction. A second way to illustrate is if we think of our rule of division. So for example, if we had x to the fourth power divided by x squared. We know that the rule when dividing is we subtract the exponents. We would take 4 minus 2 to get x squared. Okay, well what if you had x squared over x to the fourth power? Well, once again, we subtract the exponents. 2 minus 4 would give me negative 2 this time. So x to the negative second power. Well, what does that actually mean? Looking here, we have 2 x's on the top, and then we have 4 x's on the bottom. When I divide, I can cancel things out. So like these right here would cancel out, and that would give me 1 over 1. These could divide out. We'd have 1 over 1. And we're left with a 1 on the top, 1 times 1. On the bottom, we have x squared. So that is also the same thing as 1 over x squared. So notice, negative exponent means that we have a fraction, 1 over x to the positive second power. Now let's get some practice with negative exponents. If we had 6 to the negative second power, and you were to write without negative exponents, what I would do is I write this as 1 over 6 to the positive second power, which would be 1 over 36. If we had 2 to the negative fourth power, we would do 1 over 2 to the positive fourth power, and 2 to the fourth power would be 16. So that is 1 over 16. 4 to the negative third power is 1 over 4 to the positive third power. And 4 to the third power is 4 times 4 times 4, which is 64. Example 6, we have 5 to the negative first power. This is the same thing as 1 over 5 to the positive first power. 5 to the first power would just be 5. So my answer is simply 1 over 5. Okay, here are some more examples, but now the negative exponent is in the denominator. So what I want to do is we are dividing by 6 to the negative second power. All right, so we're dividing by 6 to the negative second power, which is the same thing as 1 over 6 to the positive second power, right? Because this bottom, that is the same thing as this. So when I divide, I have to multiply by the reciprocal. So that becomes 1 times 6 squared over 1, or 1 times 6 squared, which is 6 squared, or 36. All right, so this is kind of the long way of doing this, and we can actually think of a shorter way. So with any of these, with the negative exponent, to get rid of it, I simply move it from either the top to the bottom or from the bottom to the top. So right here, it's in the bottom. To make it not negative, I move it up to the top. So this becomes 6 squared on the top, right? 6 squared, which is 36. So we can save ourselves the hassle of doing this process right here in the middle by simply just moving it to the top if it's in the bottom, and if it's in the top, we can move it to the bottom to make it not negative. Here's another example, 1 over 2 to the negative fourth power. To make this into a non-negative exponent, I can take this and move it to the top. So that becomes 2 to the positive fourth power on the top, and so it's just 2 to the fourth, which would be 16. Example 9, same thing, 1 over 4 to the negative third power. To make it not negative, I move it to the top. So this becomes 4 to the positive third power, which would be 64. In example 10, 1 over 5 to the negative first power. To make the exponent not negative, I can move it to the top. So that becomes 5 to the positive first power over 1, or just 5. Now let's put this all together with some other examples where we have maybe 0 exponents, we have negative exponents on the top or on the bottom, or maybe even both. So example 11, we are given this expression and we are told to simplify. Now it looks really intimidating because of all the negative exponents. But as we begin, notice right here, this in parentheses is being raised to the 0 power. Anything to the 0 power is 1. Right? So what I have is 5 to the negative first power times 1, which would be 5 to the negative first power. And now the instructions are to write this without negative exponents. So to make this not negative, this is going to be 1 over 5 to the positive first power, or 1 over 5. Example 12. Now this looks really confusing maybe because we have just all letters for our expression, and then we also have negative exponents. So remember what we said at one point in this lesson, that to make this not negative, we simply move either from the bottom to the top or from the top to the bottom. So that's what we're going to do. So notice this p to the negative third power. I can move that to the top to make it a positive exponent. So on the top we now have p to the positive third power. This p to the negative first power, I can make this not negative by moving it to the bottom. So that becomes a p to the positive first power down there. And then this q to the negative second power, to make it not negative exponent, I can also move that down to get q squared down here. So I have now this expression with all positive exponents, and I can finish by simplifying. P to the third divided by p to the first. We can subtract the exponents. 3 minus 1 gives me 2. So that's p squared over q squared. And that is my simplified form. Example 13. We have p times q to the negative second power divided by p to the negative third power. So to simplify and to write this without negative exponents, I'm moving only the ones with negative exponents. So see here the p to the first power. That's already a regular expression. That's p to the positive first power. So no need to move that over. So that stays in the top. Q to the negative second power. To make it not negative, I can move it down to the bottom. That's going to be q squared down here. And then p to the negative third power, to make this not negative exponent, I can move it to the top, and that becomes p to the positive third power. So I multiply those together, p to the first times p to the third power. That gives me p to the fourth power, and then divide that by q squared. And that would be my solution. Here is another example. We have p to the negative first power times q to the negative second power divided by p to the third power. So to begin, p to the third power is not a negative exponent, so that can stay down in the bottom. All right, and then p to the negative first power, to make this into a positive exponent, I need to bring this down. So that becomes p to the positive first power. And then q to the negative second power, I need to write without the negative exponent. So I can bring this down to make it positive. So this becomes q to the positive second power. And then 1 is on the top because there's nothing else up there. So my solution is going to look like this, and I can combine p to the first power times p to the third power. We add the exponents, 1 plus 3, to get p to the fourth power. So we have p to the fourth power times q squared. So that would be my final solution. Here is another example. So now we have numbers thrown in here along with the variables and exponents. So to begin, I can do the 6 divided by negative 2. That would give me a negative 3. That can go on the top, negative 3 over 1. We see the x to the first power. That's already a positive exponent. So we have x to the first power right there in the top. That stays where it's at. And then y to the negative first divided by y to the negative first. We could move things around to make it into a positive exponent, but I can just realize the fact that we have something divided by itself. So here we can actually divide these right off the bat. So those are gone, and the only thing left is x to the negative second power, and to make this into a positive exponent, I bring it to the top. So that is going to be x to the positive second power up in the numerator. So now I have negative 3, x to the first times x squared would be x to the third power over 1, which would leave this right here as it is. Now to finish off this lesson, we're going to combine our idea of negative exponents along with our different rules for exponents. So for example, we have our products of powers rule, where we have two things multiply together, and if the base is the same, we add the exponents. So now if we had 3 squared times 3 to the negative 6 power, we need to do the same thing as we would with positive exponents. So we can add 2 plus negative 6 to get negative 4 for my exponent. So this would be 3 to the negative 4th power, and it's typically best to write this without negative exponents. So I can write this as 1 over 3 to the positive 4th power, which would be 3 to the 4th power. That gives me 81. So that'd be 1 over 81. Now if you are dividing things, you need to subtract the exponents. So if you had 3 squared divided by 3 to the 6th power, we would subtract the 2 minus 6 to get negative 4. So 3 to the negative 4th power, as we stated before, is 1 over 3 to the positive 4th power, which is 1 over 81. If you have a power of a power, you need to multiply the exponents. So for example, 2 cubed to the negative 2nd power, we have a power to a power, so we multiply 3 times negative 2 to get negative 6. So 2 to the negative 6th power, we can write this without negative exponents, and that would be 1 over 2 to the positive 6th power, and 2 to the 6th power is 32. So that would equal 1 over 32. Now if you have a power of a product, so two things in parentheses multiply together, raised to a power, we raise both or all the parts to that power. So for example, you have 2a to the negative 4th power. You can think of this as 2 to the negative 4th power times a to the negative 4th power. So what happens is we can think of this as 1 over 2 to the positive 4th power times 1 over a to the positive 4th power. And then you can multiply 2 to the 4th times a to the 4th to get 16a to the 4th for the bottom. So we can think of it like that. Also, we could have just simply seen that 2 and a both are to the negative 4th power. So I could have done that as 1 over 2a to the positive 4th power and gotten the same thing, 1 over 16a to the 4th. But if it's helpful, we can think of this as being separate as well. So 1 over 2 to the 4th power times, and then 1 over a to the 4th power. So either way, we get the same solution. And then if you have a power of a quotient, so a fraction raised to some power, we raise both the numerator and denominator to that power. So for example, 3 over 4 to the negative 3rd power, that is the same thing as 3 to the negative 3rd power over 4 to the negative 3rd power. And then to make this not negative exponents, I can move this either to the top or the bottom as necessary. So 3 to the negative 3rd power, you move this down to the bottom to make it into a positive exponent. And then 4 to the negative 3rd power raised to the top to make it not a negative exponent. So that would become 4 to the 3rd power over 3 to the 3rd power. And that's going to be 64 over 9. We're going to have two examples where we need to use these different rules. So example 16, we have a to the negative 3rd power to the negative 2nd power. So here we have a power to a power. We multiply the exponents. Negative 3 times negative 2, that gives me a positive 6. So my solution is a to the positive 6th power. One more example, we have 2a cubed b to the negative 1st, and then raise that to the negative 2nd power. Now remember that this exponent of negative 2 goes to everything in parentheses. So 2 to the negative 2nd, we have a cubed to the negative 2nd, so power to a power we multiply to get 3 times negative 2, or negative 6 for the exponent. And then for the b, we can multiply negative 1 times negative 2 to get positive 2 for the exponent. Now from here we can simplify and get rid of the negative exponents. The b squared is already positive, that will stay in the top. 2 to the negative second power. Alright, that's got to go down to the bottom. So that's going to go down here. So that becomes 2 squared in the bottom. A to the negative 6, to make it positive, move that to the bottom as well. So a to the positive 6 goes down here. So what we have is b squared over, and then 2 squared is 4, and then a to the 6th power as well. So this would be my final solution. And that concludes our lesson for today. We will see you next time.